All right, guys, so in this last section of Unit 7, we're going to talk about the volume for two final figures, one of which is a sphere. The other are what are called composite figures. Really, volume of a sphere is the only new formula that we'll get today. With volumes of composite figures, this is similar to something we did when we were looking at the area for composite figures, where we're simply going to break the figure up into smaller pieces and then find the volume for the corresponding parts, adding them together at the very end. But before we do that, let's talk about the volume of a sphere and what a sphere is. So a sphere is the set of all points in a space that are a given distance from the center. You could think of spheres as being kind of like a ball, like a baseball or a basketball. Not so much a football. A football would not have all the points that are equidistant from the center. So you have to be kind of careful with saying it's a ball, but for the most part, that's a pretty good way to think about a sphere. When we find the volume for a sphere, we have a different formula for that compared to a lot of the other formulas that we've seen. Our volume for a sphere is found by taking 4/3 multiplied by pi r cubed. So quite a bit different from our other formulas. Notice instead of having 1/3, we have 4/3, and so on. All right, so let's do some practice with this. We've got a few examples to look at for spheres in particular, and then we'll take a look at some composite figures. So for the first sphere, we have our radius, which is 12 centimeters. So that's going to be our R value. And notice that that's really the only thing you need to have to put into your formula, since everything else is already given to you. So when we put that in for our R value, we're going to have 4/3 pi multiplied by 12 cubed. And once again, what you'll do to simplify is multiply all the numbers together, which are not pi. So multiply together the 4/3 and the 12 cubed, and that's going to be 2,304. And then you'll put pi after it, and then make sure to include your label, which is centimeters being cubed. For the second example, we're going to do something very similar. The only really difference about it is we are given a diameter rather than a radius. So for our radius, we'll just take our diameter of 18, cut it in half, which is 9, and now we've got what we need to put into our formula. So again, 4/3 pi r cubed is our formula for the volume of a sphere. So now that's going to be 4/3 pi multiplied by 9 cubed. And to simplify one more time, multiply together the 4/3 and the 9 cubed. That's going to give you 972. Then just put pi after it and include your label, which once again is centimeters being cubed. All right, one last example for us to look at for spheres is what to do when we have a semi-sphere, in which case we're just going to do our normal volume calculations, and then at the end we'll divide everything by 2. So notice that we already do have our radius right here. It does tell us that that distance is 3 centimeters. So we can go ahead and go straight to our formula. So again, that's 4/3 pi r cubed. In this case, we'll put in 3 for r. So that's 4/3 multiplied by 3 cubed. And then to simplify, we'll multiply together the 4/3 and the 3 cubed, which is going to be 36, and then we'll put pi after it. Now, once again, remember that would be the area for the entire sphere, but we really only want half of that. So let's take what we just got and divide that by 2. And that will tell us the volume for our semisphere, our half of the sphere, is going to be 18 pi, and then make sure to include your label, which one last time is centimeters being cubed. All right, so we've got 4 more examples to look at. We're going to, really just 3 examples, I think will be plenty enough of composite figures, and then that's going to be it for Unit 7. So the last thing that we are going to talk about are what are called composite figures. So composite figures, when you want to find the volume for that, you're going to break it into 2 basic figures and then add their volumes together to get the composite volume. So for our first example, when we take a look at this, we've really got kind of two pieces. We've got, I'll call it piece A, which is the semisphere on top of our second piece, which is the cylinder, which I'll call part B. So let's go ahead and find the volume for part A first. Remember, that would be for a semisphere taking 4/3 pi r cubed, and then at the end we'll divide by 2. Now, for our radius, we need to look and see what that would be. We do know actually our diameter, which was 12 meters down here. So take half of that, would be 6 meters. There's going to be the R value that we'll use actually for both our semisphere as well as our cylinder. So let's go ahead and put that into our formula to see what we get. So that's going to be 4/3 multiplied by pi multiplied by our r squared, which is, or r cubed, which is 6 cubed. Now, when we multiply those together, we're going to, and when I say multiply together, I mean these two parts right here. We're going to get 288, and then we'll put pi after it. Now remember, that's again the area or the volume for the entire sphere, and we really only want half of that. So our area for part A is really going to just be 144 pi, and then we'll include our label, which is meters cubed. Next, let's go ahead and find the volume for our second part, which is our cylinder. Remember, for our cylinder, our formula for that is we're taking pi r squared multiplied by the height. Now, we already know that r is equal to 6. We also know that our height is equal to 5. So let's go ahead and put those into our formula. So we're going to have r squared, which is 6 squared, multiplied by our height, which is 5. Now, to simplify, what we're going to do is we're going to take our 6 squared and 5 and multiply those together, which is 180. Then we'll go ahead and put pi after it, and then include our label, which is meters cubed. Now, in order to find our total area, we're just going to simply, or our total volume, we're just going to add those two separate volumes together. So we're going to take 144 pi plus 180 pi. And in order to add those numbers, just add together the numbers that are in front of pi. That's going to give you 324, then write pi after it, and finally include your label, which is meters cubed. All right, so two more examples that we're going to take a look at here for us, and then that's going to be it for this unit. So for this next particular diagram, we've got, again, two pieces. We've got a cube, actually, or a rectangular prism, if you want to think about it that way. And we've also got a pyramid on top of it. So let's go ahead and do this. Let's go ahead and label this part, part A, and this part, part B. So for part A, what we're going to do is we're going to find the area, or our volume for our cube, which, if you want to think about it in terms of a rectangular prism, would be length multiplied by width multiplied by height. And it really doesn't matter what you make what. In fact, for a cube, those are all equal to each other. So that's just going to be a volume of 6 multiplied by itself 3 times. And so that's going to give us a volume for our cube of 216 feet cubed. Next, let's go ahead and find the volume for our second part, so part B, where for a square pyramid, remember we're going to take 1/3 its base multiplied by its height. Now, the base of this pyramid is this part right here, which is a square. Remember, this is a length of 6. This is also a length of 6. So for the base of our pyramid, we're going to take 6 multiplied by itself, or 6 squared, tells us that the area for our base is equal to 36. We already know our height that was given to us in our original problem. Our height is equal to 6. So putting those into our volume formula, we're going to take 1/3 multiplied by 36 multiplied by 6, and that's going to tell us that the volume for part B of this is going to be 72 feet cubed. Now, to find the volume for the entire figure, we're now going to add together those two separate volumes. So we're going to take 216 for part A plus 72 for part B, and that's going to add to be 288, and then we'll include our label, which is feet cubed. All right, one last example to look at. Let's go ahead and take a look at it now. So we've got our composite figure, which it looks like is made up of a cone and a cylinder. Let's go ahead and call the cone A, and we'll call the cylinder figure B. So for the volume of figure A, where we've got our cone, remember that the volume formula for a cone is that you take 1/3 pi r squared multiplied by the height. So taking a look at our diagram, we already know our height is equal to 9. We know our diameter is 6. So let's do this. Let's go ahead and find our radius, which would be half of 6. 6 divided by 2 is 3. So our radius is going to be equal to 3 centimeters. So putting those into our formula for the volume of a cone, we're going to have 1/3 multiplied by pi multiplied by 9 squared, or 3 squared rather, multiplied by our height, which is 9. And to simplify that, anything that's not pi, we're going to multiply together. So that's 1/3 multiplied by 3 squared multiplied by 9, and that's going to multiply to be 27, and then we'll include pi after it. Next, for figure B, let's go ahead and find the volume for our cylinder. Remember, for our cylinder, we're going to take pi r squared multiplied by the height. And once again, we already know what r was. We just found that was 3. For the height of our cylinder, we know that that's equal to 8. So putting those into our formula, we're going to have pi multiplied by 3 squared multiplied by 8. And then to simplify that, multiply together 3 squared and 8. That's going to end up being 72 multiplied by pi. From there, we're now ready to find the volume for our entire figure, where we're going to add together our 27 pi along with our 72 pi. And when we add those together, 27 plus 72 is going to be 99 pi, and then make sure to include your label at the very end, which is centimeters cubed. All right, guys, that is it for this section of the notes, and in fact, that is it for this unit. So in our next class period, we will begin to review and get ready for your test, and then test should be about 1 week away from today. Until next time, guys, have a great rest of your day.